Good morning or good afternoon or good evening, whenever it is for you when you're watching this. This is the notes, the video for the guided notes for Unit 1, Lesson 4. So we're talking about midpoints and bisectors today. So we talked about general vocabulary, lines, line segments, rays, and then we talked just about line segments and the special thing that line segments do, right? You can add the two pieces together to get the whole. Now we're going to talk about special line segments. We're talking about line segments that have a midpoint or a middle point, right? Middle point. Basically what we're saying is that they are cut in half. So a midpoint is halfway through a line segment. Okay? And that's what this is saying over on this next line, right? That if I tell you M is the midpoint, then I know AM is equal to or congruent to MC. All right, so we could write it that way too. So it's a point halfway between two other points, and then I get two equal halves, right? So if I want to find the midpoint, let's say I want to find the midpoint of EF. So here I have E, and here I have F. All I have to do is count from one side to the next. So I count in one, I count in one, I count in one, I count in one. And then I say where they meet. Oh, they meet right here. Well, this is 2, 3, 4. They meet at 4. So 4 must be the midpoint of line segment EF because line segment in point 1 is at 2. Line segment, or point E is at 2. Point F is at 6. Halfway between 2 and 6 is 4. If I wanted to find the midpoint of DF, I do the exact same thing. Here's D, and here's F. I'm going to go 1, 2, 3. 1, 2, 3. So I went the same number in, but wait. I landed on 2 for the D point, and I landed on 3 for the F point. Well, what's halfway between 2 and 3? 2.5 or 2.5. Your midpoint can be a decimal. It can be any number as long as it's between the two endpoints. Okay, so let's look at this next one. I know an endpoint, and I know the midpoint. So here's my endpoint, and here's my midpoint. I need to find the other endpoint. Well, it works the same way. If both pieces, if both parts of the line segment, both halves are the same value, so I'm going to put a point at -1, and I'm going to count how many units to get to my midpoint, which is right here. Okay, so I'm going to go 1, 2, 3, 4. So I went, whoops, I forgot to change back to blue. I went 4 units, okay? From left to right, I went 4 units. So now I'm going to go 1, 2, 3, 4, because if I went 4 units to get from one endpoint to the midpoint, I'm going to count 4 units to get from the midpoint to the next endpoint. So once I count 4 units, I land at 7. All right, so you're going to use a number line, and on Edpuzzle, you're going to answer the next one. You're going to start at 12. I insist, actually, I don't just recommend, I insist that you put a point at 12, and then you put a line at 7, even though it's not written the number 7 on your paper, it's right there. And count your units, 1, 2, 3, 4, 5. And then you're going to do the same thing going this way, going to the left, because I think it's reversed in the camera, to find the other endpoint. Okay, now you're going to do this next one. Exact same process. Put a point at 3, count to 5, and then count again to find your next endpoint. All right, so that was looking at numbers on a numbered line. That's one dimension. Now we're going to look at numbers on a coordinate plane, and that's 2 dimensions. So I'm looking at this, and I'm told that I have a point at 2, -7. Please fix your notes and put a -7 up there, because that's where it is. So here's 2, -7, and here's 2, -1. Okay, and I'm going to do the same thing. I count. If you need to, take your notes and turn it so that your picture is horizontal and the line is horizontal and not vertical. But if you can see it without that, that's fine too. Okay, I'm going to do the exact same thing. I'm going to count. So -1 to -2 to -3. So I went 2 units down, 2 units up, 1 more unit up, 1 more unit down, and I land at -4. That's only half my answer though, because remember I'm in 2 dimensions. So I need to plot the point. My midpoint is at what point? What what is this point right here? Well, I didn't go off of x being 2. I just changed my y value. So x was 2 for the endpoints, so x is going to be 2 for the midpoint. Because I didn't travel, right? I didn't go left or right. I stayed on my line. So I know you guys are dying to know, but wait! What if the line isn't vertical or horizontal on a coordinate plane, right? It's got a slope to it, right? More than the slope of 0. It's got an actual slope of like 1/3 or 2/7 or 5. Oh man, I quit. No, don't quit. Don't quit. Don't even panic. This is the formula. So if you want to do this the way that we've taught it in the past, awesome. What you do is you sub your numbers in. So this would be x1, and you put that in for x1. This would be y1, and you put that in for y1. This would be x2, put that in for x2. And this would be y2, and you put that in for y2. So you label your points, okay? I named this x1 because it's the first point, so it's the first x I see. And then you plug your numbers into the equation. You do substitution. You can type the formula in and use sliders, and you get the answer. But wait, there's an easier way to do it. Go to Desmos. Do not go to Desmos.com, though. Click on the icon on your computer right now. So minimize the video, go and click on Desmos. And you're going to click on the keyboard right here. And you're going to go to Functions. And you're going to go to Miscellaneous. Look at the very bottom. It says Distance, which we're going to use next time, and Midpoint, which we're going to use now. So we're going to go to the midpoint. And you have to put each point in parentheses. So I'm going to put the points in exactly the way that they're on the paper. Okay. There's a comma between them because I'm listing points. And then I have 2 parentheses. I want it just like that. There's my answer right there. 3, 1. That is the midpoint. And I'll prove it to you by showing you what these other 2 points are going to look like on the line. Do you see now how my midpoint is between the 2 points? So all I have to do is use Desmos. Make sure it's in Standards of Learning version. Make sure this green line where it says Virginia Standards of Learning version is at the top. Or you're not going to find that app. Okay? Okay, so now what you're going to do is you're going to do the next problem. You're going to put those points into Desmos using the midpoint trick. One of your answers will be a decimal. And now you're going to do the next one. And you can see how my points are decimals, right? -6.3, 5.2, -1, 1.8. So your answer is going to be decimals. Decimals. Okay, so put that into Edpuzzle using Desmos. Awesome. Now what we're going to do is we're going to do this. And like before, we're given an endpoint and a midpoint, but we have to find the other endpoint on Desmos. Okay? Not as hard as you think. So hold on. All right, so what I'm going to do is I'm going to actually just enter my points in. So I'm going to put the point 0, 4 in. Whoops, I forgot to put a comma though. And I'm going to label it so I know where it is. And then I'm going to put the point -5, 8 in. And just like before, I count. If you can't see it, move your graph around a little bit. Okay, I'm actually going to, whoops, I'm going to do it this way. There we go. So this is my endpoint, and this is my midpoint. So I know my other endpoint is somewhere up here. How can I find it? I can count the slope, just like you did in algebra, right? They're going to all be on a line. It's a line segment, so I can find the endpoint. So I'm going to start here at 0, 4, and I'm going to count up. 1, 2, 3, 4, 5. And then I count over. 1, 2, 3, 4, 5. That's wrong. I made a mistake. This should have been a 4. 1, 2, 3, 4. Yeah, it's 4. Sorry. So you count up 4. Count up 1, 2, 3, 4. And then count over 1, 2, 3, 4, 5. This is what you did in algebra. So now to find my next point, I do the same thing again, right? Because the next point on the line, I just follow the slope. 1, 2, 3, 4. 1, 2, 3, 4, 5. And I go right here. So my x value, if I put my cursor there and I use my finger and I go down, my x value is -10 and my y value is 12, right? You see that? If you take your finger and put it on the screen, you trace it, you will see that your x value is -10 and your y value is 12. Oh, look at that. It worked. Who knew? All right, so now this is what you're going to put down. We found the answer, and I gave you the directions on how to do it, right, on your notes. So I want you to write this down on your notes because you count up and over, okay? So now, what I want you guys to do is I want you to draw these on your notes. You're going to draw a segment, so a line segment, being bisected by a line, okay? And we're going to check it. So I'm going to, where would I put this? Well, if I put it right here, that's great. But how do I show they're equal? How do I show these two pieces are congruent? Remember, you got to put those little marks on the line, right? That show that they're the same. Okay? I'm going to give you a hint down here. A perpendicular bisector means that it intersects at 90 degrees. So not only do you have to put your congruent symbols, but you also have to put this little symbol in the corner. Okay? So when you show your intersection, you have to have that little square in the corner. So I hate it when it does that. So I want you guys to go ahead, ignore the squiggle, and fill in your notes, right? And we'll check them. If you need help, just ask. That's what we're here for, okay? Last but not least, I'm going to show you how to do the one on the left. We're putting everything together from the notes. This is all the information that we've gotten, and then you're going to solve the one on the right, okay? So I'm told RS, so this line, is a bisector of AB. So automatically, before I read any further, I'm going to mark these two pieces as congruent. Because if it's a bisector, that means it cuts it in half. Okay? A bisector cuts it in half. Oh, you could use this on your poster if you have time to work on your poster again. So you're cutting this in half. Okay, that's what that means. So when I see the word bisector, I can automatically mark these two parts as congruent. Okay, and then I know that AM is 2x plus 5, so I'm going to draw on my notes. This is 2x plus 5. I'm going to look at my picture. Please draw. Please mark up your paper. There is no way that you can get through this without marking up your paper. You can, but you're going to make mistakes. All right, so let me rephrase that. There's no way that you can get through this successfully. All right, so now what is the length of AB? Well, the first thing I'm going to do is I'm going to add my two pieces together. Oh, wait, but I don't have a length of AB. I don't add them. What else do I know about those two pieces? They're equal. I know they're equal because I marked them as congruent, because I know the definition of a bisector is telling me those two pieces are congruent. So I can put this into Desmos, and when I do, I get x equals 4. So let me put a box around the question and see if it matches the answer. Length of AB. X equals 4. Does that say AB equals 4? I don't think so. So am I done? Nope. Like we did with line segments, now I've got to go back and I have to substitute that 4 back into my original equation. So I'm going to say 2 times 4 plus 5. And that is equal to 13. But that's only AM, right? AM is equal to this. I need the whole line segment. Well, wait, if this side is 13, then this side is 13. So couldn't I just say 13 plus 13, right? Because that's my piece AM is 13. If AM is 13, then MB is 13. So if I add my two pieces together, I get my whole. So now I want you to go on over to Edpuzzle. I want you to do this problem right here. Exactly the same problem. You have all the information you need to be able to do it. I even drew you a picture. Label your picture, do the problem, put the answer in Edpuzzle. Thanks, guys. Awesome.